So, hi guys, I'm Dilip Shiva. So, am I audible to everyone? Good morning. So before we start anything, I just want to take a quick survey so that I know, where you are at. So I just want everyone to go to this URL, GitHub Talks, Dilip Shiva /talks.
Hey, Dilip, 1 second. There's the Wi-Fi and the password. If someone has missed it, just the @ symbol 2016. Please make it.
Yeah, and I was also told if someone is also on proxy or a static AP, please remove it from your DNS configurations. So in the talks, if you go to issues, there will be an issue. I just want you guys to go there and vote. You can open the links in new tab and just start voting it so that I have a better idea of the kind of audience that you are. Oh, sorry. So this would be. Oh, it's not audible. Is it? Where is the speakers? Oh, what is it? Am I audible now? Okay. So you can visit GitHub. Dilip Shiva /talks on GitHub, and if you open the issues, I just want you guys to visit this URL and start voting. Oh, just open everything in your tab. Right click and open everything in your tab. New tab. Oh. Yeah, so that you don't have to come back and forth on it.
With the technology audience,
Where did you share the link?
It's on GitHub /talks. If you go to the first issue.
this is like to get the audience.
Yes. Oh, yeah.
Session is going to be focused on results you run.
Yes, I will.
What that help you. Right?
But if you want to get the full effects of it, it's Windows. But I think it's still okay. I have tried on Windows 2 it works in the past, so you can pick it up. But the session, the speaker will be more driving to Linux or key types. You can choose one you want.
Oh, most of it like DevOps exposed. Go to never your basics, somewhat efficient, advanced. Never used. Oh, not yet used. Sorry, yeah, Docker. Most people, like majority of them, never use it. So we will go through basics. AWS is sort of okay. At least most people know basics. DevOps. Manually available. Huh? Manually available. Most people, very little and manually. Huh? This is these are like awesome guys. I hope. I want to ask them how they do it. Huh? No, just if they're willing to. I'm not going to point anyone. Okay, I think that would be enough. Not right now. Yeah, this is just the option station. After the build. Yeah, after the build, you might or if you want to do some more points of like not. No, I don't want to interrupt. Okay. It looks very bad. Okay. I'm just telling you if you have any ones.
So virtual machine is good enough.
Sorry, what?
Linux.
Yeah, I think virtual machine. Okay. So, okay, first of all, I would like to thank Venture City and Accion Labs for, So, first of all, I would like to thank Venture City and Accion Labs for providing me this opportunity to share about you guys. And yeah, so before I begin, I will. Okay. Okay. So a little bit about myself. I'm Dilip Shiva. So basically, predominantly I'm a developer. I code for web, mobile, and embedded devices. And on top of that, I do a little bit of this and that, like DevOps and other things as well. So that's pretty much about me. And the next thing. So I have no idea what I'm talking about. So everybody is a learner. So except for the top 1%, nobody knows anything. Nobody knows anything much of. I mean, they're not an expert. Is really what I'm trying to say. So if you happen to come across something that I might have misrepresented, or if I've got wrong idea about something, please please feel free to stand up and correct me. I would. I love those kind of feedbacks, so don't hesitate. So yeah, so prerequisites, this will come back later when we want to do a demo. At the moment, we don't need it. So okay. So before we begin, I want to know what's your idea on what DevOps is. So anyone can do give a definition or something? Not a definition, just give me a general idea of what you think that DevOps means.
When we develop, we maintain all operations.
Okay.
Deployment, everything is done the same.
Okay, awesome.
Or the continuous deployment of the.
Okay, good.
It's about agility and automation.
Okay, awesome. So, anything else? Okay. So yeah, it's basically what all these three people said. That is DevOps is so. I don't know why, but there is a misconception. First, as a first thing, I want to clear those misconceptions. Everybody equates. I mean, most people equate DevOps with sysadmin. DevOps is far more than a sysadmin. So that is what I'm going to try to explain for the next few slides. So yeah, to start with, to understand why, to understand DevOps, you should first understand how it came to be. Right? So we'll talk a little bit about what happened before the DevOps movement. So in old organizations, right, people usually used to work in silos. Silos as in separated, independent teams, where there will be developers and there will be system admins and there will be QA guys. So developers, they just code. They don't do anything else. Most people don't even write test cases for whatever they have coded. They just push the code, and the other guys, QA guys, they take the code and then they test it. If there is any bug or any issues with the code that they written, they write it. They'll raise an issue, and they'll have to fix those issues back again. And then when the QA team is okay with that, they will let the ops guy, the sysadmin guys, know that this code is okay to be deployed. And that is when the sysadmin guys will try to take the code. Most of the times, the code is a black box to them, as in they don't understand how the code really works or the inner architecture. They will get a bunch of instructions from the developers on how to deploy this application. So if I want to deploy a Django app, I say I need a Python, this version of Python, and I need all these requirements to be installed, and all these libraries and all these extra tools that I want you to install, and the ops guy takes those this thing and sends it to the mission. And more often than not, more often than not, there is no production parity between the developers' missions and the production missions. They're bound to miss some some minor detail or something that required for the app to work, and that's a very long cycle, which takes like insanely long time. So I don't know in my personal experience, but I've known people saying that it might take anywhere from weeks to months to push the code that you have written into production. So that was like that has a very bad feedback loop. If there is any issues, you're not able to fix it. You may right then and there. You will have to go through the whole cycle once again to fix it. So that that wasn't very efficient. So that is when the DevOps movement came in. So basically, the guys that drove this movement, or basically these giants like Google and Facebook, they're the first one to come up with it. Google, Facebook, and AWS, of course. So they figured out the problem that there is this problem because there's no intersection, right? It just happens like in stages, and there is not really a link between those two guys. So what they thought is, we really need to have a specific set of guys who know to do all these things together, so that they can act as a link between all the three things. So that is what they called it as DevOps. So most people think that DevOps is something that you do at the end, as in once your product is built. Only when your product is completely built, the DevOps may come into the picture where we just deploy to the server, but that is a wrong assumption. The right assumption is the DevOps guy should be there from the beginning, working along with the architects or something, to help them design the app so that he can properly. So he should basically have his opinion should matter more when it comes to architecting the application, so that it can be deployed onto the servers and scaled. So that is how DevOps came into existence. So if this is not my opinion, right? And without data, I'm just another man with opinion. So you guys need to look at the roles posted by Google and AWS for their DevOps roles. So more often than not, every single one of them, you will be required to write programming. You will be required to create tools to help developers deploy the app, and you will play a predominant part in architecting the application. And so you will be there from the beginning, not just in the end. So that's what a DevOps engineer is. So can we? So yeah, so that is the sweet spot. So we are between development, QA, and operations. So the idea is to automate everything, like one of you guys mentioned. Not just the deployment. For deployment to successfully, to reliably work, that, I mean, if you have to ensure that whatever you're about to deploy in an automated fashion, that will not break the server, you first need to have automated test cases which will run in every time you commit and push the code, it should, report you back with any broken pieces of code or something like that. So yeah, it is not just automating your deployments, it's automating everything within your team. Like from even before the beginning of the code, with the architect, automate the test cases, write some test cases, ask the developer to write some test cases, and then when the test cases pass, you deploy to the production directly, and then you get all the logs which are generated, because if there is any error, logs is the first thing that you go for, and that logs should basically be able to, there should be a pipeline where you should be able to go and see into the logs like a single story, and if you do find out an issue, you put it up on a bug tracker or something where these people will take it up and the cycle continues. So that is a very fast cycle. So within a few minutes of coding, you know if your code is broken or not, if someone is broken or not, if someone has broken your code or not. So it's like minutes. What has been like weeks has been reduced to minutes now. So that's the whole idea behind the DevOps. So not just deployment. So I just want to set that thing here first. So yeah, next thing. So it's all about collaboration, right? Like there will be a DevOps engineer. DevOps engineer doesn't necessarily replace a sysadmin. So even at the places like Google and AWS, there are DevOps guys, but there are also sysadmins who does pure infrastructure work and nothing else. And DevOps, these engineers acts like a bridge between the developers. They also code themselves. So if you are not coding, you're basically not a DevOps guy. So that is it. Can yeah. So that is basically so whatever I said. This is a proper definition of DevOps from Wikipedia. So there runs through like 183 articles written on DevOps by the giants like AWS and Google, and they come up with this definition. So I don't think I need to read it out. It's there on Wikipedia. So it's just collaborating and automating. So that is it. So DevOps is not one single thing, right? So it's actually multiple smaller things built together, which revolves around all these things, which is from code, build, test, package, release, and configure and monitor. So DevOps has a predominant role to play on all these parts. So I'll explain each and every one of them with what part that the DevOps engineer needs to play. So yeah, from the code, right? So the work of a DevOps engineer starts even before the code starts. So me as a DevOps engineer, I would first set the entire, the process of the organization. So that usually from the code. So we have like multiple code hosting repositories. You have GitHub, you have Bitbucket, you have code-based HQ. So that's whatever you use. That's just the thing of your choice. So I've also seen multiple people who like I'm not sure if anyone is here out here now who does that, but I've seen a couple of people who don't use any of the source control. They just they just work on different parts of file. At the end of the day, they sit together and figure it out. This actually happened. They sit together, they figure out which part of the code should go where, and there'll be this one guy's machine where they just code. And some other people. So these are the teams that I came across personally. And some people work on, I think Google Docs or something like that, because there multiple people can work together, collaborative stuff. So they just type whatever the code that they want. So there's a single point of source. They just copy paste the entire thing into local stuff or download it and run it. That's like the lamest thing that you can do, and that takes like a lot of energy. And if someone is doing that, I hope not. Don't do it. So use a source control like more often than not people use Git because it's become more popular. and there are multiple other tools. It is not the only container space. So you have Network, you have SVN. SVN is very old. But yeah, I always prefer to use Git, and you should have a proper bug tracking, place where you can track all the bugs. So basically, if you're using GitHub, GitHub offers issues support. Most of the people should know that. But that's not the only place you can have. But you can have, like I've seen teams which have code hosted on GitHub, but they track all the issues on Jira, because Jira helps much organizing the issues and these things much better. It has like a Scrum board where you can put your stories. Yeah. So Jira has the thing where GitHub doesn't have that thing, but recently GitHub came with this feature called projects. You have organizational projects where you can just create an issue, but still no one except your admin has, I think, access to those projects and stuff. So what I use in such places is I use these tools like Battle and Tagia. Tagia is an open source application. So these are like essentially Scrum boards. So let me just show you how Waffle looks like. So this basically is our Scrum board. So we organize all our issues here. It's pretty much a little bit outdated. So as you can see, we have multiple issues. If for the uninitiated who don't know what Scrum board is, so this is what particularly a Scrum board looks like. So we have backlogs, which are issues to be worked on, and then so when it is ready to be worked on, say we set sprint, right? For us, every sprint lasts 2 weeks. So whenever there is a new sprint, we put everything on the ready state, and whenever someone is working on it, for example, you can see that without asking my team members what they're working on, I'll know what they're working on, because whenever they work, they are supposed to move this to progress. And if I need to review any pull requests, that will be over here, and all the closed pull requests, as you can see, this is all pull requests. All the issues will be assigned to their pull requests as well, and it will be here. So this is basically your Scrum board. So this helps keep track of your team, so that each one of your team knows what the other one is working on. There will be no. People will not be stepping on each other's toes. I've come across even situations where there is issues and multiple people, 2 people just start working on the same issue, not knowing the other one is working on it. So yeah, this is a nicer way to solve it. So yeah, that's basically.
So how you assign. Also, because in track and plan or using, you can do one thing that you have created the story, then you have created the task under the stories, and you assign them and then they will work on it, then they will update. Like here, how you assign the task?
Okay, so here basically the thing is, this thing is tightly integrated with GitHub. So whatever issues that you see here is an issue that's directly on the GitHub. I hope Tagia is also working on the same way. So if you click on this thing, and if I click here, as you can see, it takes me to the GitHub issue. So we have specific people working on specific roles. Like I work on integrating everything together and architecting and at that level. And some people we have different services. We have front-end services, back-end services, and there are like scanners and device farm. So people belonging to that listing, we just say, these are the issues, these are the features that we require this month, and it is their responsibility to take the relevant issues, assign it to themselves, and work on it. There are rare cases when we work on it when there is a change of priority or something like that. But it's essentially, we are like, I don't know, we don't have a central point of this thing where people will assign us. We just assign it to ourselves and we just start working. So I'm pretty sure that's not how most teams work. Every team has their own dynamics, but this is our dynamics. So.
Issues assigned.
No. Once the issue is assigned, no, it doesn't mean it is fixed. It's just assigned that who will work on that. Yeah. Yeah, nobody else. Yeah, should not work on it. So yeah, that's basically about your code. Next slide. Okay. So that's not the end of it, right? So issue creation is just one part of it, and there is this other part where you work on say features without stepping on other people's toes. Like more often than not, if you have used Git and stuff like that, you will see that. So you can see that whenever you push the code or pull from the remote, you more often get some conflicts, which are a little bit harder to resolve, because you'll need both people who are responsible for the conflict to sit together and figure it out. So and there are many other things, right? Like I might be working on something which is not finished yet, but some guy has just finished some feature that he wants to push, and he want to be able to do that without without the feature that I am working on. I mean, with whatever that I am working on, that should not affect what he is doing. So for that, we go with something called we go with grid branches basically. So branches says, so I'll just explain what branches is. So this is Vincent Dirisel's branching model. It's called a successful Git branching model. You can Google search for it. So his post is like the go-to reference for anyone who wants to implement the branching kind of workflow in their environment. So only half of the slide is here. So basically we have many branches, right? So there is a master branch. So master branch, you never commit anything on the master branch, and you rarely commit on developer branch. So the purpose of the master branch is that the master branch will always have the stable code. So it will never have a broken code, it will have the well-tested stable code. So the idea is to, whenever something is merged into master, it should get automatically deployed to your production service. And whenever you commit something to your developer, you don't commit anything to your developer, you rarely commit to it, you should try avoiding it. But whenever some feature branch is merged into developer, it should automatically deploy it to your staging service. So if I'm working on something, say I'm working on a blog, like a blogging agent, and I want to create a feature for commenting. So I create a branch. First I create an issue, and I reference that issue with the number from on my branch. And I say I'll create a new branch called issue number slash whatever your branch name is, comments, your feature is the comment. And then I start working on it. So does multiple other people start their own workings also. So there will be a different branch for handling, like say, rating posts, or a different branch for managing users and stuff like that. So whenever their feature is completed, they send us a pull request. So basically, they have all their test cases written. So I can even show you a demo on how it works. With where I'm working at now. So basically, whenever the test case is passed, which means and the coverage report say, okay, you have covered most of the codes, I'll just merge it into my developer, and I test it, and that gets deployed on either it gets deployed manually onto the staging servers, or it gets we haven't automated that yet. So or it gets automatically deployed. So when we automatically deploy it, once we manually log into the server and to see if everything is working, that is not required, but that's just like an insurance policy. So when everything is okay and we figure out, okay, everything is stable and no more changes are required, we merge it into master. So that will get automatically deployed to your production service. So that's how it basically generally works. And you cannot always write a bug-free code. There is somehow there's bound to be a bug that goes into production. So in such scenarios, you create a hotfix branch. You branch off from master. You create a hotfix branch. You merge it into master again, and then deploy it. And whatever hotfix you have, you again merge into develop, so that every other get is like updated. So that's basically how you should be. So there are like different strategies to it. People work on different things, but so this is followed by like the giants, Google and Facebook. So I think the guy who wrote the post is from one of those giants, I don't know which one, and he wrote the post. So this is like the most followed Git branching model that there is. So Waffle actually follows this model as well. So when you, there are specific ways in which you can name your pull requests or issues. It will automatically group your issues and pull requests together in the Waffle template, so that there is a, you know, it's all like a summary for you. So yeah, that is all about that. Okay, so next is the test builder package. So this is the other part of half of the story, right? So the developers are expected to write, yeah, the developers or the order is a little bit necessary to be test build and then run. So developers write test cases. So they write their unit tests and integration tests. You should always make sure that your test cases cover most of the use cases. There might be some special edge case that you should put. Basically, you should just put some extra efforts in figuring out the edge cases and then covering them. So when you have like no one can have like 100% coverage. Coverage is basically for the people who don't know. So so coverage is basically a metric that says how much percentage of your code has been covered by your test cases. So when you say if you have 100 lines of code, when I say I have 80% coverage, which means 80 lines of code are being tested. I have written tests for 80 lines of code, and you can never write test cases for if your test case, your coverage will not be 100% because there is going to be just assignment problems on the. So yeah, the better the number is, basically I would say any percentage above 85 is like a good coverage for any given use case. So yeah, that's basically what coverage is. So when you have more coverage and when you have this test cases written, you can be like very sure that nothing has broken. So when multiple people tend to work on a project, they tend to take say APIs. I would expect a function to get 2 arguments, but my friend would have got to take a 3rd argument and pass it. So had you put proper test case in it, that would fail in your CA server, and you get reports to it. And the way to run these test cases are, as most of you know, there are like things like Jenkins, Travis, Joel, Circle CA. There are like multiple things available for you, and everything has its own advantages and disadvantages. Basically, it's up to your team to go with whatever CA server that you want. So CA servers are the servers that build your test cases for administration. So whenever you commit a code to, whenever you commit a piece of code, the CAs will make sure to put your code onto their servers and run all your tests, and if there happens to be some error, you will go back to you saying, do something is broken. And the next thing is, okay, so the build and package, that is just a generic this thing, because people working in Java might build their this thing, I don't know much Java. But when you work on dynamic languages like Python and Ruby, there is no specific build stage because there's nothing to build. So and then finally so package is just the run phase where you actually run those services. So basically, I'm going to cover. I mean, I'm going to hit on this point again. So I'll just leave it for now. Yeah, the next thing is to release and configure. So release and configure. So I've seen many people, right, committing like sensitive data like API keys and API secret this thing to the Git, which is like a very bad idea to do because so this is coming from a personal experience. So what happened once was I was working at this startup, at some other startup, and one of my colleagues, he basically just stole the code and sold it to the competitors. And you know what? So the code is gone. That's fine. We can always build upon on top of whatever we have already. But the thing is, not only the code is not lost, our infrastructure is basically at risk now because it had the secret keys. It had the Django secret which generates the cookies. So people can basically fake requests now, or they know our AWS credentials. They know our all the keys for our database, which was back then it was like RDS. So if you know your username and password for your RDS, anyone will be able to log in. So that, the customer's data was also on stake. So it's never a good idea to submit your secret keys to your listing, which will basically come from your environment variables, where one guy has like an access. Most often than not, if it is small team, most often than not it is the CTO, so he'll access. So even in my listing, I've told my CTO that I want any key, so he's the one who, if we need to change any variables, any values, so he'll change the values and update the environment variables. I just read it from the environment variables, so that all your keys are safe. So so release and configure stage has something to do with that. So whenever basically you want to deploy something onto your servers, you just put your configuration files there, and you have some specific commands to run in case of Django to either to the server, and yeah, things like that, right? So that is basically your build and configure stage. So yeah, so last but not the least, there is also monitoring your applications, right? So I've seen most people just log into the production server and look at taking the log file and stuff like that. But that's generally a bad thing to do, which makes see if your developers need access to your logs, you basically want to give them SSH access, which is not a good idea. If not, if there is a single point of entry, like only you are able to SSH into the server, then every single time he wants to check if something is wrong, he has to get back to you. So that is like again a convoluted thing to do. So easiest thing to do would use a monitoring stuff or a log, a server that collects all the logs. So we basically use something called ELK, which is Elastic Log Stash Kibana. If anyone has heard of it. So whatever logs that we get is so I didn't implement it, so one of my colleagues implemented it. I don't know about the details, so correct me if I'm wrong. So we just write it to a syslog, and then there'll be a logstash server which will be listening to the syslog event, and it fetches all the logs from there, and you basically use Kibana to just analyze your logs. It has like a single point of truth. So being a microservices company, we have like multiple servers running, multiple services running, and we even have a device farm at our office. So for you to, if you have to diagnose what the problem is, you have to go through it step by step. Like, okay, there is a request from one of our front-end servers which came to the back-end servers, which came to our device farm. So you should be able to trace back that step. So with ELK, we'll be able to trace back the steps now, because there's just all the logs are just in a single point of place. So that is about this thing, and we also have some application performance monitoring, right, APMs. So basically, when you hit as long as everything is working fine, you wouldn't need any of those things in an ideal world. But it is not an ideal world, and every now and then you'll hit some problems, right? So you'll need to figure out where the problem is originating from. Say for some suddenly, your response time might be like slow. Usually it is like 200 milliseconds, and suddenly it has gone to 1.5 seconds, and you have to figure out what went wrong. For that things, you need to implement some sort of application performance monitoring, which will say. So you need to capture metrics from each and every point of your applications. Only then you will be able to find out where the error is actually originating from. It might come from the views. You might have written a bad sort of a sorting algorithm or something. It might come from there, or it might come from your database where it is taking a very long time to resolve a query. Probably you have to make joins. So if you had to figure, where the problems originating from, you should have APMs, and more often than not, I see teams not doing it. And when you really hit a scale, right, when say that if you start if your traffic spikes up or something, you'll not be able to properly look into the problem and resolve it. So that's basically what DevOps is. So I'll conclude that with saying, if you've just been pushing the code manually to the servers, you're not a DevOps engineer. That's not how a DevOps is defined. I'm not judging or something. I'm just saying to have the wrong title. So a DevOps engineer is either a developer who is who's very interested in programming, and as a programmer who is very interested in deployments and networking and stuff like that, and take care of the deployment process in your team, or is either a sysadmin who had a really good interest in programming and is sort of trying to connect with the at programming level, not only trying to give you feedbacks on how to architect it properly to properly deploy it, but also he's able to contribute something to your this thing. So he is the DevOps engineer. So that's how a DevOps engineer is defined. So it should be both a developer and a sysadmin. So yeah, that is it. First, I want to clear that off the table. Some of the true stories which would have been very hard if I was not a DevOps engineer is, I use a Mac, and like I said, we have a device farm which has Android and iOS devices. So whenever, for that you need a context of what we do. So I basically work at this startup called AppNox, and the tech lead with and DevOps over there. So what we do is we scan Android and iOS applications for security issues. If your app is vulnerable, basically the developers and the companies would come to us saying, asking us to check if their app is secure or not, and more often than not, we find some vulnerability, and that's what we do. And we have a cloud-hosted tool, where you can upload your APKs, or we also act as a CI ourselves, as in a security CI, not a functional CI. So as you commit your code, we can pull it from GitHub and build the APK and run the APK to this thing. We don't need source code, we just need the APK files. So that's what we basically do. We have a cloud-hosted tool where where you upload your APKs and we run it through our scanners, and if there is any vulnerability that we come across, and we report it. So for this particular feature, we have this thing called the dynamic scanning. So the dynamic scanning is when so you start a dynamic scan, your app will be installed onto a device which will be installed on an Android or iOS device, which is in our office. So we have an in-premise device now, and that will show up on your browser. You get to interact with your app on the browser in real time, and if we did find some issues, we collect it and report it back. So that's basically one of the features that we built. So initially, I used some tools. I usually built on my Mac. So I used some tools. While the Android solution was working just fine, when I deployed it, I actually found out that whatever tool that I used for interacting with iOS applications is not working on Linux, because it's Linux. That tool already assumes that you're on Mac, and that binary is available at that path, so that you can grab the binary and just install applications, remove applications, and do your utility function for you. So I didn't know this. It was an NPM module. It was called iOS deploy. So yeah, and then we deployed it, and we figured out that the Android was working properly when we deployed it, but not the iOS. So had it been a silo kind of thing, had we been an organization where I'm just the developer and I have this guy who sort of maintains it, it would have been like a real blame game, that I'll say it's working fine on my machine, works on my machine, and he'll say, no, you basically missed something, and we try to sit together and resolve these issues. So that would have taken like weeks. So because I know, because I found out personally that it didn't work. I was able to resolve it like much quicker, and I had all these logs in place, which also told me, because I could never figure out where the problem actually originated, because the architecture is like very complex. Backend has to come pass through the front-end server to the backend servers to the device farm and then all the way back. So that was like, I mean, that would have been like real complicated. So this is just, you know, one personal example that I could give, but you know, DevOps really solves most of the other problems that I found in this lesson. So yeah, that's basically. So okay, this will come later. So this is just an intro on how what DevOps is, and I hope I solved some misconceptions about the DevOps. So this is all the theory that I have. Whatever I have next is except for the little part where I talk about you know, 12-factor app. Everything else is going to be a demo. So so are we going to have the break now? At 4 plus. So
For we start with us.
okay, so I can continue now. Okay. So I just want to see. Okay, so so 12-factor app, right? So who here has heard about 12-factor apps before? Okay, so a 12-factor app basically it's a set of guidelines that predominantly the guys behind Heroku, you might have known Heroku. So they came up with this set of principles which says how to write a scalable app. So so by scalable, you know, so not only this, if you follow this principle, your app will be scalable. You will be a proper DevOps organization if you do follow these principles. So I just wanted to quickly, you know, talk about those 12, you know, commandments. And the first, or so yeah, the first is the code base. So like I mentioned before, so you should use your you know, there should be some sort of source version control. It doesn't matter what you use, whatever that you're comfortable with. And the second one is dependencies. You always explicitly specify your dependencies. Like I'm not sure about the other you know, stacks like Java and .NET. So we have you can take, for example, Rails. So Rails has your gem file where all your dependencies are, you know, it's like explicitly mentioned where it has, I need this library of this version. So on Python you have requirements.txt. So you should have all your you know, requirements to be explicitly declared over there, so that you know, it becomes easy for from an ops perspective to sort of you know, install all those requirements on the machines. So there is no verbal communication from developer to the ops guy over here that these things are needed to be installed. So that's all, you know. So whenever you change or whenever you want to add, you just specify it in your file and it just automatically works. So basically, before moving on, I realized I missed a really critical part. So ideally, what a DevOps guy should do is apart from, you know, the obvious collaboration and automation stuff, is to give a platform, for the developers to deploy and, you know, to deploy and test or scale whatever that they wanted. So basically, what I do is, so I use this open source PaaS application called Delis, DELS. So you have many you know, open source solutions like Delis, Flint, and there are some others as well, Doku. So I'll be able to use this, and I'll be able to define users and say these as users have access to push these applications, and the developers do not need to worry about you know, deployment scripts anymore. For them, deploying is as easy as doing a git push. So if you have used Heroku before, that's exactly what I'm doing my dev team. So I have built this infrastructure, I've added all the users, so I just give them the dev team, so I just give them the access, and they just do a git push, and if they want to scale, they just have, if you have used Heroku before, you basically say Heroku app scale, and whatever service that you want to scale, you do it, right? So yeah, yeah, whatever they do will be horizontal.
Vertical.
Yeah, vertical I'll take care of. Okay, so how many of you have used Heroku before? Oh, so maybe we have
Ruby on Rails deployment.
sorry.
Heroku is Ruby on Rails deployment.
No, not just Ruby on Rails. Yeah, you can deploy Django, you can even deploy, yeah, Node.js, everything. Oh, okay. So Heroku is a PaaS, which is a platform as a service. So what they give is basically a set of commands that you can execute on a local machine, and they take care of running the servers, making sure it is always running on those. So, no, not AWS. No, it's a standalone company. It was acquired by Salesforce, but then it was an independent company. So Heroku is not the only guy in this space. So there are like many people, many PaaS providers. Like, yeah, AWS also, yeah. So you have like multiple companies. They provide this platform for you, and they say, okay, if you have to deploy your application, you structure your application.
Basically for deployment.
Yeah, basically for deployment.
Or hosting.
For hosting. Yeah, basically you just follow their commands, and you don't need to worry about your scaling your servers or ensuring that your servers is always working. So
you have an application and they will give you something by which you can manage. It's like managing the services, managing the application.
yeah, so you don't need to write any scripts or maintain the infrastructure. That's basically basically you maintain your infrastructure, right? Say if you are an AWS, you need to take care of backups. What if one of the servers goes down, or if there is a regional disaster or something like that. So you need to take care of backup. You need to make sure you write proper, use something like supervisor D or something to make sure that your application is always running. And when you want to scale out, you need to add more services, sort of load balance. You again need to configure all the load balances so that you can load balance between traffic between the instances. So that part you don't need to do. You just tell them, dude, I want this Python service running, and they just run it. And then there'll be a command which will say Heroku scale web is equal to 3 or something. Then you instantly have 3 services running. Sorry, yeah, they themselves use container within this case. Yeah. So basically, that's what Heroku is. Yeah. I forgot what I was talking about.
Dependencies.
Oh yeah, dependencies. So those guys require you to keep your dependencies in a specific file. If it is Python, they expect it to be deployments. If it is a node app, they expect you to put a package.json. And they just read from that thing and they install it. So that's basically what a DevOps should do. So he should give, like when I asked the question, you build products for dev team to use. If you mind sharing your this thing, I think 2 people did that thing in DevOps experience. Okay, that's fine. So yeah, basically I use days. I just give days. Now all my developers will be able to push into not into production. Production only me and my CTO have access. For the staging environments and testing everything, they can just do a big push and we deliver with it. So if you want to talk more on that, I can probably take it offline. I think we have questions on that. So config, yeah, again, store your configurations in your environment variables. So if you use something like Heroku, you can do a git config push. So basically, you can have your configurations not on your git, but on a separate folder somewhere, right? For example, my CTO has somewhere in his local system where he just types a command to push those configuration files into the DS cluster that I have, which I don't have. I mean, now I'll basically not be able to look into this thing and to know if I turn able the company's. So yeah, and backing services. So backing services, apart from the tools that I've built, right? So you have built your Python server. So that is the only resource that you need to worry about. So everything else should be treated as a backing resource. Everything else as in you have Postgres. So Postgres is not something that's built by you, right? So that's just a service that's running something. So that's a backing service. And you have, say, if you have implemented something real time, you have Pusher. So Pusher is now a backing service. So everything should be treated as a backing service. And you should have featured flags that say, suppose say your Postgres service is down and nothing is happening. Say your real-time server is down. Say you return, you used pusher, but pusher is down. You should have feature flags where you can just go and disable it in the environment, so it won't try sending notifications until the pusher server is back up. So you'll not get many, those 500 errors or the other protection errors. So everything should work like a feature flag. So feature flag is basically that you have many features. Like I said, pushing notifications is a feature, sending email is a feature. If one of them is not working, your app should not fail. You should have a checkpoint in proper places saying that, okay, now I don't need to send emails or notifications based on the variables that you set, and you should be able to do it. So by doing that, you ensure that, even if these services are not available, your app still continues to work without causing a traffic trouble. Sorry?
You mean to say we should not be saved?
No, not locked services. So what I'm trying to say is, feature flags are basically some variables, right? So if I need to talk in programmer terms, it's some variables that you set to true or false. So if it says send notifications equal to true, it will try to connect to pusher service to send your notifications. Or it will not. If you have not done feature flags, say if for some reason pusher is down, then basically the entire app is going to fail, because pusher will raise whatever client that you are trying to interact with pusher, that will fail, which will cause the subsequent failure in all your this thing. So that's why feature flags are important. So you just enable or disable for any third party or external dependencies. It will just shut down and everything else will start working like a regular thing.
Like in maintenance, you can put something.
Yeah, exactly. In maintenance, you can put some features. So yeah, build, release, and run. Again, touching the same point. So if you're on Python or Ruby or Node, there's nothing to do. But if you're on Java, I think you should build and get a jar file or something and run it on the server. So that's so that's the build phase. So the build phase would essentially happen after your test cases pass. Only one and only if your test cases pass, you should build, or else it doesn't make sense. What's the point in building a program system? So yeah, that is the thing. And then there is a release. Release is when so as I said, your config are no longer within your app. That is coming from a different place, which is environment. So release is the stage where you give your config files to your whatever build, either a build jar file, or in case of Python, there is nothing to build. You just pass it directly to your process. So you should pass your environment variable to your app. So that's basically your release stage. So release stage might happen at different stages, right? For different places. There might be a development release, there might be a production release, or there might be like an internal alpha release or something like that. So you might have used a different, say you might use different S3 bucket for development and for production. So those are all the variables that we pass in that stage. And then you go on to the run stage where the actual application is up and running. And there are processes. So everything should run as a process. So like I said, Heroku. So in Heroku, you describe your processes, right? You write the special file or top file where you specify, okay, I need a web server to be running. So for a web server to be running, I need to run, if you're on, say, Django, manage.beware answer is the command. Or if you're on Rails, I think it's Rails DXC. And if you, so each platform has its own specific version of running your data. So that is what you specify in your proc file, which is a single process. And then when you want to run, if you want to scale it up, you just say, in case of Heroku, you say Heroku scale web is equal to 2. Now you have two web processes running, so it can take twice as much as traffic than one. So that's basically running your thing on processes. So the advantages. So I've seen people assigning roles to servers. Even I myself used to do that 2 years ago. So we have specific servers, specific roles for servers. So I have a DB server. will be running the Postgres service. And then I'll have a web server where I'll be actually running the Django or whatever application, right? And there will be like a task server which runs the worker process and stuff like that. So for me to scale a server means to add one more instance. Say if I need to, if I'm suddenly facing more traffic right when you say, and I have to scale my dev instances. So I put another server, run another process on it. So it is sort of like you add more instances. But the thing is, not all the time, you're making 100% usage of the CPU. There might be, it might be 70%, but you cannot still use that 70% because you need to give a buffer space. What if you get more requests suddenly? Every request is going to fail. So you need to leave a buffer space. And when you start leaving buffer space in each servers, like 20, 30% here, 30% there, 30% there, and to altogether you have like multiple, you have like plenty of CPU time remaining now, which is effectively being wasted. So if you have written it in process mode, right, and put it in something like a Docker container or something, you'll be able to specify, you can just have, instead of scaling like multiple times, you can just say, okay, on this server, just run a Postgres container. And this server, you can, and also run a Postgres container over there because it is working like a process. And eventually, you might end up saving more of those CPUs thereby using like, this is like, I'm making it sound way simpler. I'm probably not 10,000 folds simpler, but there are many more metrics and mechanisms to it. So basically, the thing is, if you're able to run it as process, and if you're able to increment process whenever you want to scale, you basically are left with very least number of. You can run more services on least number of instances. That's basically it. But I can try to explain when I'm giving a demo. That will probably clear you up. We have a AWS demo. So I'll probably try explaining how to run two Docker containers on the same system so that you make maximum use of your instance. So the next is port binding. So you have multiple services running, right? So I have a web service running, and it should talk to my worker, which is running elsewhere, a task worker. So how am I enabling the communication between two? Is through port. So my worker process is running on a different port, and my web server is running on a different port. So if I should be able to identify them, I should assign specific ports for each of those services, and then send requests to those services. We have like so we have other tools to do that for people who don't know much about basics. This will be a bit confusing. So, but for the people who already have some experience, we have ETCDs. You have console. So these are all like service discovery. So you have like many services running, and this ETC data or console will have is a repository of all your running services and their ports. If I have to simplify, if I have to put it in layman's terms. So whenever you want to say talk to a worker, you ask your DTC D that dude, I need to talk to a worker. I need to talk to a worker. Can you please give me the port and IP of the worker? We'll give you the port and IP, and then you connect to that port and IP. So basically, it should all connect to ports is the base point, and so concurrency again, it is dependent on the process that I talked earlier. So if you are able to model it out as a process rather than to have like one process for like an instance, so you'll be able to scale out much easier with way lesser resources. So this basically is the 12-factor map. I might have messed up some points, but there is this site 12factor.net. So if you visit it, they have written it in a much clearer manner than what I was able to come up with. So I advise everyone to go there. So yeah, that is it, I think. Oh shit, I forgot. Okay, I explained only. So disposability. More often, not more often, but I've seen few people, right, have a stateful web server, as in so basically you guys have what what an idea of stateless and stateful is, right? So a stateless is basically when you say a service is stateless or a web server is stateless, what it means that it doesn't hold any critical data for you to care about that service, right? I've seen many people, right? I implemented this thing once, even I myself did it in the past. So I have this socket service which sort of holds all the data to whoever is connected on what room or they subscribe to. And the problem with that is I was not able to scale more than one process because it's all the data is in memory. Whoever connects to it is I just put it in a special object and I query that object. Now I'm not able to scale it because my service is stateful and it has all the details. So for me to make it stateless, I should persist that data somewhere else. Right? So I use Redis. So when I use Redis, I use the service just like a proxy to my Redis. So whatever clients that come in that are subscribed to a channel, I just persist on Redis. Now no matter how many services that they have, they have a single point of truth. And I can discard any one of them at will, and the others will be able to still manage without any errors. I mean, work without any errors because the data is stored in a central place. So that's what basically a stateless service is. So you should be able to discard any of your services at will. If not, you are in a real trouble, and you should be looking to like alternatives of where to store it in a proper place so that the other processes can look into it and take decisions. So that's basically disposability. You should be able to discard or scale at will. That's the only way you will be able to scale.
You were talking about security information or any other state?
No, not just security information. So it might hold like So I have a user who wants to listen to a particular event for a file, right? So that things might go on a different room. So all those rooms, not just security, this thing, all the data, especially whatever data that is, not specific.
You want the services to scale independently.
Yes.
Right? So it does a state within the service, and if you bring that service down, and another instance will not have that state with it.
Yes, yes.
So that's to keep that state, are you saying use Redis, or are you saying
No, yeah, to keep the state, you use Redis or something in the lines of Redis, right? You can either use Redis or like if you want to maintain session, you can. Yeah.
like a cloud session?
Sorry.
Like a cloud session.
Yeah, as in not
Session
cloud
like like authentication and these kind of information.
Sorry.
Redis is used for maintaining a cloud session in
Oh, okay. I've never used Spring. Yeah, but it has like multiple applications. You can use it like a queue. Yeah, you can use it as a cache. So yeah, that's basically the thing. And DevOps protection parity. So like I explained before. Yeah, it is. I mean, it all depends on how you architect your application, right? Okay. Yeah, it will scale for a lot of users because it's in memory. Scale for a lot of users, but at the cost of being reliable. As in, if your Redis instance itself goes down, then basically your entire data. Okay. Okay. For me, I mean, for me, I've always never had much of traffic because I always tend to work on enterprise companies where the traffic is planned and limited. So, but it should be able to scale. You just put up a Redis cluster, and it should be able to do it.
what I understand is that you keep your application in stateless. The security information which unless you're doing sticky sessions, you want to give a user a seamless login. So it doesn't have it's logged on into one instance of a microservice, and it's not able to when
Yeah,
this service
right.
goes down and he suddenly logged in. and either way, you give him, you give the actual effect of the user is login.
People use that as well.
Because no one wants to make stateful applications these days.
Yeah, no one wants to, but some people, because they're not aware of all these things, they tend to make, especially people who are just starting out. So yeah. The next thing is the dev production parity. You should try to keep your dev machines as much similar, your development environment as much similar to your production environment. Like I mentioned before, I used an NPM tool called to interact with iOS applications, and it was not working on Linux. So had I used a Linux machine, I would have known that, and I would have given, and then we have to go back and re-architect just the iOS part of it, because I didn't know about these things. So you should always try to maintain identical environment for both your developer and your production machines as much as possible. And also there is other instance where I always use SQLite for my local development, and when it goes into production, I have configuration files to use the Postgres. But then I figured out there was some integrity error, which I'm not sure which I covered what, which SQLite didn't capture because it is not really asset compatible database. It's just it is, but it's not that powerful, right? You cannot write like triggers and stuff like that. So I had to go back and run this server again to figure out where the error is actually happening from. Try to keep your services as same as your environment as same as the production environment. You'll save a lot of time. And then there is logs. And like I said, there should be a single point of entry where you have all your logs stored in. I always use ELK stack. There are many other third-party services as well, like Part1. There are plenty of other open source things as well, but for me, I've always found, and I have found a problem with the ELK stack. I suggest the same. So ELK is again Elastic Logstash and Kibana. Logstash is actually the logging server. So Elasticsearch is just like a store where you store all the data. So Kibana is the dashboard where you just visualize all your logs and stuff. So you can put like metrics, and you can say, okay, whenever you find this particular data, so you can actually create charts and stuff. So that's basically what it is. There'll be some admin process, right? Every now and then you need to run a migration script, or you need to set specific statuses for some users. So that should be ran as an admin script where you run from your local machine. There should be a way for you to run, run it from your local machine, so that you can change your data over the production this thing. So when you use something like Heroku, they say Heroku has its own inbuilt command called Heroku run. So whatever run command that you give, it will actually go and execute in the context of your application. So that is one of processes. So if you ensure that all this fundamentals are baked into your application, you're basically making sure that your application is basically able to scale properly now. As a DevOps engineer, I don't have to worry about thinking if I put it in 2 instances will it run or not. I'm pretty sure that it will run. It can run. That is pretty much about the 12-factor app. But I really strongly suggest you to. I'm sure I messed up some parts. You should visit 12factorapp.net to read it yourself. That is it, I guess. Next we'll have a couple of demos, and I'm not sure what the time is.
No? So we can wait for a Q&A and then.
Oh, okay. So far, if you have like any Q&As, I'll answer.
So how does these days you come across the vision container, right? You come across this concept of container development. There are at least 3 or 4 companies which are creating these container developments. Like Google is one, and Red Hat is one, and there are many others. So do you think the
No, I don't think it is getting reduced. I think it is, even if you have containers, it is the responsibility of the DevOps guy to enable those things for you, right? No, not always. So he don't have to code. He doesn't have to code for setting up an infrastructure. Yes, but he should be involved with your development team and to ensure that whatever you will write is something that you can just go ahead and deploy without any change. So there is still a role for him. Uh-huh. Sorry. Okay. Okay. Sorry. Okay. 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 Um, yeah, I am not sure if that is typically the case for every. Yeah, deployment can happen. Yeah. So so yeah, I think when you put it like that, I can see that maybe, but but it's still someone who is sitting there and writing those solutions. Yeah. Sorry. Yeah.
So there are many companies like IBM is also giving, and also Azure also is providing.
Yeah.
You can,
So
yeah.
one of the places where we see a lot of that is where
Yeah, exactly.
one of the
Okay.
apart from that is like developers we talk about that all in so we just keep the numbers to the other thing is that there was people are doing is trying to make sure that we want to make sure that the activity and all this is maintained properly. So that's what we do. Although we are in the last phase of make sure that we just have to make sure that we are using the services okay. Again, we also go through there are what is doing so we will continue writing after this system there always I'm currently working in Skype. What I can say is it's not about you can look at the logs to it. You can take the logs to take to without doing the research. So you have whatever you expect to do from a DevOps point of view, and you don't have to worry about separate. So it's all about logs. So what sort of concept you can get the logs. So we do the much better than you probably that's probably but definitely the
And still in video
Just to add here, I would consider DevOps as more of a mindset. You will get more and more tools. There are going to be more and more tools coming, and I welcome all the tools. Thanks, that all came because of DevOps. So possibly there are going to be more tools which are going to come to make our life simpler as developers. Right? That's how I look at it. It's a mindset. It's a way of thinking, right?
So all our developers are DevOps. So that line that the DevOps is going to do this, it was specifically going to do that. So we have to pretty much guard that line and the way it depends on each location. So one of the challenges which we had is that we got when the error comes, so what we do is that our developers also know that so each of our developers is also DevOps. So the way I look at it is DevOps is more application operation rather than exactly what is in there. Exactly faster and I don't allow my developers to do create system so that solution is still very good, but the deployment and all these things is pretty much done on the
Yeah.
We follow that very good. You keep the window for developers to deploy that. I mean, I'm just giving another aspect because so I have seen that you actually literally move from that model to whatever you and from
Next. No, you are also supposed to know a little bit of code. Yeah, so no, code as in not necessarily you need to know to build the product itself. Because like I said, so if you're not at the least you should know to deploy using Ansible or any Capistrano or something. So yeah, that is it. So for Python you could go for something like Fabric. We have Fabrics. In fact, that is what I'm going to show the demo with.
without knowing the coding like Java and all, we can't even do it.
Sorry?
We know Puppet, we know the Puppet DSL, and we know scripting, we know the code of Docker work. So we are not DevOps.
No.
Straightforward question.
I would answer that. If you deploy it and your thing is used live, a lot of people, you don't use any tools, but your server goes up always and your users are
I have
happy.
no idea how my application is built, what code has been used in that. But yeah, I know how to manage the infrastructure, how to scale it up, how to deploy the codes using Puppet and Chef, and I know how to run containers and all.
Then you know all the tools. Then you know all the tools of
I don't know
DevOps.
the coding part, like if the application is in Java, whether it is using Rails or what, I don't know. No idea about that. That is just part of development. I have no idea. They don't tell me. Just give us the code to get deployed, use our Puppet run and all those commands to deploy it to the server, send it to the server as a file. So we are not developing.
No, but then again, if you use tools like Puppet and Chef, you can be classified as.
No,
But yeah,
if you
it's
look,
not required.
No, if you look at the 12 steps which is thing, these are things, right? Those 12.
Basically for developers.
No. Those are tools. You can use tools or you can need not use tools, right? You can do whatever you want to do, right? They can be developed in any language. They were not specific to Ruby and Rails. They were not specific to C# or they were not specific to Java, right? So I think the 12-point rule answers your question. Because they don't belong to any particular technology, right? And these are things what you do in the deployment when you have to do deployment. And if you know how to do it.
12 factor what is mentioned here, that is not necessary to know if like if you are have good hands-on experience with Puppet, Chef and Docker and all such type of DevOps tools. You not to know about those 12 factors.
So you think it's a one-time learning or it's a continuous learning? People can see things as two type of ways: one-time learning, continuous learning. I look at DevOps as a continuous learning,
exactly.
right? If you look at a one-type learning, then you can actually restrict yourself to a Chef, Puppet, and other tools. So how you look at it, and depending on what context you are, how you look at it.
I just don't want to go to the coding stuff, coding part and all. Since we are DevOps, straightforward question. I can't go completely.
Yeah, DevOps is basically optional. No, but then that's again the sysadmin, right?
So you're looking into a sysadmin job.
Okay.
Maybe you should ask first, can I become sysadmin? Yes, you can become. But those jobs are going away.
Not necessarily the production coding, but at least the infrastructure.
And again, it depends mostly on the company. Right?
Yeah, it depends on the.
Very much depends on the company or the actual DevOps or DevOps or Ops, how you will go. And that's
Sorry? Wake up now?
It's at 4:30.
Oh, okay.
We can start.
It's at 4, so I can start with the demo.
Yes.
Okay. Okay. So who here has signed up for the free tier on AWS? Okay. Who here has not signed up or don't have access to it? What I can suggest is, you can probably, and I'm not sure about Windows, I've never used Windows SSH and all those things. So if you are on Windows.
So for Windows, you have to download Putty and use the SSH keys to add it, and then you can SSH directly to Linux instance.
Yeah, that much I know.
otherwise you can download the bash.
Yes.
So
Putty is very easy. You have to copy paste and then.
Keep the IP address in the authorized keys and then hit login, it will log into the machine.
Okay. So for those who do not have the free tier thing, I would suggest you to sit with someone else who has.
Or you can log into, I think the form, Venture City form will give you automatically access to the $100 credits.
But that was saying invalid. That was yes. I tried it. I had a previous access I'm using for 2 months, but the moment I applied that coupon code, it said invalid.
You used, I think you must have used the same email address for it.
Okay, but that was not specified. It was written like whether you are having it or you don't have it. Previously you are having or you are creating new, you can use that.
I think
so I used the same email address.
So if you use the same email address, Amazon will discuss. You have already an account. So if you already have an account, I think you won't get $100 free credits.
So is there anything that can cost? Anything in the that you are going to get?
Yeah, that will, but that can cost you like 10 rupees or something if you use that. but you still need to pay.
We can't do it on.
No, we can do it on free time. This is for people who do not have free time. You can either sit with other people or you can choose to pay, which is very easy. Probably the cost of a coffee. So who in here has already used AWS or are familiar with AWS a little bit at least? Okay. Oh, you guys fill this thing. Okay. Huh?
Windows users, you can ask them to download at least.
Okay. Yeah. Sorry? I couldn't hear it. Okay, Putty. You can answer that.
Yeah, yes, create an AWS account and
It's asking you the coupon.
once you fill up the Venture City form, I know that you receive an email with the coupon code. I exactly don't know the procedure. I think Vikas will make.
But if you are registering now, then you need a credit card or something.
Oh yeah, I think for the first time.
They will deduct and they verify.
I should start. Or should I do like 5 minutes for them to download?
If you have 5 minutes, then
Okay.
if they don't have, they can get a free dial card and get a free dial.
Okay.
They don't charge for only at the computer.
Yes.
Yes.
Yeah, there is also a separate Docker session, but this was about how to deploy into AWS.
That's fine.
Okay. Oh, yeah, you need VirtualBox now.
And if you don't have, if the Windows user are using old laptop.
Okay, so I'll give everybody like 5 minutes so that you can download Putty and stuff if you're on Windows, or if you have not yet signed up, you can sign up in the meanwhile, and we'll start like in 5 minutes. Sorry. Yeah. If you click on the services, you'll have EC2, and you'll have to click on the EC2. So if you are stuck somewhere, try asking neighbor, or if it is not, if he's not able to solve, let me know. I'll just assume everybody is doing it and move forward. Yeah, and you click on the launch instance. The username password. That is still not working.
That's working.
Do you have any proxy settings? Huh? You don't have any proxy.
That is okay. Okay. Oh yeah.
Is it still not working? Okay. There is an. I started my hotspot. Check for Imran Ali 11 on the Wi-Fi. EMRAA and it will be something like that. You have it? Capital I M R A N @11. Is it working? Okay, you can check somewhere near the mobile. This hotspot trend, I don't know hotspot trend.
Okay.
You can check here.
Just pull up a chair. Pull up a chair, sit here. That's it.
Okay, so we will create a Ubuntu instance for this. So 16 point, sorry, Ubuntu. What just happened? Sorry?
What? It's fine.
Which is?
So they created the first one. It's fine.
Yeah, that's fine. Any Linux is fine. Yeah, but we'll go for Ubuntu because I need to. So this is Ubuntu. Shit, sorry. Okay, you should
You
set.
can ask them to click on free tier eligible.
What? No, Windows you cannot use. Yeah. So other flavors of Linux is okay as long as you know the package managers on that platform. Like on Ubuntu it is apt-get. I'm not sure what's there for other platforms. So. Yum for Red Hat, I guess, for Fedora. No, not on Windows.
You can tell them to choose this message.
Yeah.
Choose T2 micro free tier.
Yeah. Make sure you're choosing that T2 micro free or else you'll be charged. And okay, so basically, so if you go to the next screen, you can see a bunch of configurations. So you can say how many number of instances that you want, and so there are. That's okay, I understand. So basically, there is this thing called network. So the purpose of the network is, say you have a different. If you have like a production cluster and a development cluster, right? You can basically have them in two different networks. So that one is not interacting with the other. So that's basically the network, this thing. And I'm not going to get into this thing. So R2 assign public IP will just give you a IP which can be accessed from anywhere in the world, or else you'll not be able to SSH into it. So just make sure it is, just make sure it is enabled. And IAM role, so IAM role is something like advanced. When you have teams like that, IAM is basically identity access management. So if you have like multiple people in your team, you can assign a role for each people, right? You can have a front end role, a back end role, and you can have a DevOps role. You can only give, you can only say, okay, only people with these roles will be able to log in into these missions. So that is for that team. So let's not worry about that thing now. And then, you know what, let's not just worry about any of the other this thing. The only thing that you need to worry about now is just make sure the number of instances is 1. And you can go next and add some storage. IAGB is like good enough. We are not going to do anything fancy. So if you want to create some tags to your instances, you can create it. So tags are basically how you filter your instances. Say you can assign a front-end tag to one of your instances or multiple instances. So that means that instance has your front-end services running, or you can use it to your benefit, right? It doesn't. It's basically just for you to filter your uh, instances. So we are not going to add anything over there. That's fine. Oh, or you can add a name. You have security groups. So security groups or your firewall or basically your firewall rules. So it will say what what ports to open. So you can create specific groups, right? So I can create, for example, I can create a MySQL security group, a security group for MySQL servers, where port 547, yeah. So we can just expose those ports and shut down all the other ports. So by default, it will always create a port which is just SSH 22. Only that port will be opened. And what this source says is when you type 0.0.0.0, it says from anywhere in the world you'll be able to log into it. Okay, I'm not going to get into the configuration of source because it's a bit complicated. You can also specify only from limited IPs I should be able to log into this machine and all those things with the source. And you can add more services like for now let's just enable HTTP or HTTP 80. So from anywhere in the world, just add these two and preview and launch. So yeah, so basically this gives you a summary of our whatever we want to create. So it says it's a Ubuntu mission from a T2 of a T2 instance, T2 micro instance, and we only have the SSH and the HTTP port open. And the storage and all the other stuffs are just default, so it is not going to show the default things. And finally, you just click launch, and it will ask for you to choose a key. So key is exactly what it sounds like. It's a key to log into your instance. You can either create a key, or you can use the same key for like multiple instances. So, but I wouldn't. Sorry?
So the free users will not have a key.
The free users will not have a key?
No. So the first time users
will not have a key. Yeah. So if you already have a key and you know how to SSH, that's fine. But for most of the people who don't know, just do a create new key pair and just name it as some demo or something. Okay. Yeah. Okay. Or for the people who don't know, just rename it as demo key so that I can also use the same commands. You can also use the same commands. So yeah.
Do you want?
Yeah. So you'll be given a PIM file. So mind you, PIM file is a key which you log in. So I would never recommend sharing a PIM file with anyone. So even at our startup, so only my CTO has the PIM keys. I'm only given authorization to via there is something called authorized keys, where I can give my public key, which is generated on my computer. If you don't know what, okay. So how many of you here know public key and private key?
All of them.
Okay, not most of them. Okay, so there are two types of keys. So when you use SSH authentication, there are two keys. One is public, one is private. So private is a super secret key. You never share it with anyone. And then there is this public key, which you actually share with everyone else. So the PIM key is a private key which you don't share with anyone else. You just keep it with yourself. I would always prefer just one guy have the PIM key, which is the CTO. Even in our case, that's the thing. So for everyone else, if I need access to one of the machines, I'll ask my CTO to add my public key to the authorized key list. So when he does that, without me needing the PIM keys, I'll be able to log into the machine because my key is already authorized to log into that instance. Might be a little confusing now for people who are just getting started, but I'll show you a demo. So yeah, you can launch the instance. You downloaded the key. Okay.
Yes.
Sorry. Yeah.
Download key. That is generating a RSA.
Yes.
Public and private.
Yeah, it is giving you the private key.
Private.
which you'll be able to download only once. What do you mean, how safe?
So it is generating now the keys.
Where
are the keys getting generated?
No, it is getting generated, but AWS doesn't have. So I forgot where I read it, but AWS explains how they are generating keys and stuff. Basically, no one else, even AWS, has the copy of the private key. Even if AWS wants to log into your.
Some of the providers they give you the complete control. You can actually paste the key value.
Oh, okay, I
have
am
actually generating
okay. Okay, I don't know any such people. I've only used
Here
Google.
also, like once you log into the machine, right? You can remove the publicly from the right key and then paste your own.
What the option is somebody else can log in.
No, the thing is like once the demo key.pm, whatever PM file is being downloaded, that is only once downloadable. Then by you, AWS is not keeping a copy at all. That is a matter of trust over there. In that cloud, you know that only, right?
No, but like I said, you can switch the keys with your own keys if you want. I am not really sure how to do that, but it should be pretty
So
straightforward.
like it's a private key if I want to create public key.
That is impossible.
Huh? Sorry?
It's a private key, okay, fine. So if I want to create public key and I want to share that.
Okay. No, generally when you run a SSH keygen command, you will get both private and the public keys. I'm not sure how you can create a public key from a private key. They can't, is it? Okay. I know you can. I know it is not possible the other way around. You cannot create a obviously. So yeah.